everyone, how have you been? Welcome back to my YouTube channel. It's again Mr. Tereshe on the video. Today we'll be looking at chemistry, specifically on the atomic structure. But please, before we do that, kindly please subscribe to my YouTube channel and share with others so that we may have the equal opportunity of learning together the sciences and the mathematics on my YouTube channel. And you'll be first notified when the new video is uploaded as soon as possible, and we move on together. Okay, so we'll be looking at the atomic structure. What is what is an atom? The things which are found inside the atom, and the properties of those things, and how to draw the cell structure, and the calculation of and some small calculation in the nucleus of an atom. Okay, so when looking at the atomic structure, we really have to know first the definition of the word atom. What is an atom? An atom is the smallest particle of an element which takes part in a chemical reaction. An atom is the smallest particle of an element which takes part in a chemical reaction. Now, in this atom, there are some things, or the same atom can be represented in different ways. So now the general model of the atom of any element, it should look like this. The general structure of an atom. So here we have the particles which are represented by P, and also the particle represented by N. Then around that first circle, there are also some circles which are called the shells. So in the shells, we have particles which can be represented by E, like that. So that is just the general structure of an atom. Now the parts of the atom, the inner part, the midst part, that is called the nucleus of an atom. Then these lines outside these are called the shells. So an atom, it is made up of the nucleus and the shells. Now inside the nucleus of an atom, we have the particles called the protons, represented by letter P, and the neutrons, represented by the letter N. That is in the nucleus. So in the nucleus of an atom, we have protons and we also have the neutrons. While in the shells, we have electrons. Electrons are found in the shells. The shells are found outside the nucleus of an atom. So the central part of an atom is called the nucleus. In the nucleus, it is where we find the number of protons as well as the neutrons of an atom. So upon knowing the parts of the nucleus and what is found inside the nucleus, we should be able to explain the properties of these particles which are found in the atom. So these are called the characteristic of fundamental particles, or maybe we say subatomic particles. So properties of subatomic particles, properties of subatomic particles. What are some of the properties of the subatomic particles? One, we start with the protons. Protons are positively charged. The protons, they have a positive charge, so protons are positively charged. And they have a relative mass of 1. The relative mass of 1. Therefore, protons have a mass of 1. 1 proton is equivalent to 1. Then the charge, it is a positive charge. Protons are positively charged. Then, apart from the protons, we also have the neutrons. Remember, these two, they are found in the nucleus of an atom. So we have the neutrons. The neutrons, they are neutral, or they have the zero charge. These, they do not have a charge. They have a zero charge. They are not charged particles. And the relative mass of these neutrons is also 1. Maybe it is the reason why they are even found in the same nucleus of an atom, because they have equal masses. So neutrons have the mass of 1. The relative mass of one neutron is 1. Then we have electrons. What are the properties of electrons? Electrons are negatively charged. Electrons are negatively charged, they have a negative charge. Then the mass is nearly 0. The relative mass of these electrons is nearly 0. They do not have the mass, if you look at in other topics like the radiations, the beta particle, they say it has 0, but its mass is 1 over 1840, which is nearly 0 if you divide the 1840 into 1 to give you 0.00 something. So that is nearly 0. So, but the mass of one electron is 1 over 1840. They are negatively charged. And they are found outside the nucleus of an atom. They float here because they have the very, very small mass. They cannot find themselves in the nucleus. They have a very, very little mass, such that they are just floating around the shells. Now, after explaining this, the properties of these fundamental particles, the protons, neutrons, and electrons, then let us look at the nuclide. The same element, the same atom can be represented in another way. Apart from drawing the shell like this, it can be represented in what is called the nuclide. The nuclide of an atom, it is a symbolic representation of an atom, where you use the symbol to represent the atom of an element. So the nuclide, it is a symbolic representation of an atom. Now let's say this is the symbol X. So the X is representing the symbol of an element. Then we have M there and we have A there. So when you write an element like this, then you have represented the element into a nuclide form. They represent the symbolic representation of an atom. Oh, yes. So even if it was written like this, mass or A, it's the same thing. It is a symbolic representation of an atom as well. The number on top, according to the periodic table I'm using, it is the mass number. The number on top is the mass number. So that is the mass number. Then this is the atomic number. The mass number and atomic number. What is the mass number? First of all, the mass number is also called the nucleon number. The other name for mass number is the nucleon number. The mass number is the total number of protons and neutrons in the nucleus of an atom. The total number, or the sum of protons and neutrons in the nucleus. The mass number is the total number of protons and neutrons in the nucleus of an atom. That is what is called the mass number. Then what is the atomic number? The atomic number, in this case, it is the total number of atoms, the total number of protons in the nucleus of an atom. That's why it is also called the proton number. So atomic number is also called the proton number. Proton number, it is the total number of protons in an atom. So the total number of protons in the nucleus of an atom, that's what is called the proton number. But for an atom which is neutral, or the element which is neutral, the total number of protons and electrons are the same. This is quite important. So, if an element is neutral, it has not undergone any chemical reaction, the number of protons is equal to the number of electrons. The number of protons is equal to the number of electrons in a neutral atom, an atom which is not charged. Before it loses or gains electrons, that means it is neutral in that case. So if it is neutral, the total number of protons and electrons are the same. It's quite important in the calculation we'll be doing in the next part. Okay. Now that we have known this, we have known the mass number, also called the nuclear number, the atomic number, also called the proton number, and the other things like the subatomic particles, the protons, neutrons, and electrons, and where they are found, and also their properties. Now we can do the other part, where we should be able to calculate the number of neutrons, the number of protons, and the number of electrons in an atom of an element. Okay, sorry, I'd put the data far from where I could read first. Oh, this marker is quite difficult to erase. It's difficult to erase. I never knew this. Okay, so how can we calculate the protons, electrons, and the neutrons in the atom of an element? Let's say we have magnesium. Magnesium has the mass number 24 and the atomic number 12. So we want to find how many protons are there, how many neutrons are there, and how many electrons are there. For protons, it is quite easy. Remember we said the atomic number is the total number of protons. So for number of protons in magnesium atom, it is the same 12. So magnesium has 12 protons. Protons is the total number of, atomic number is the total number of protons. So in this magnesium, we have 12 protons. From there, how are we going to calculate the neutron number? Remember we said the mass number, it is the sum of protons and neutrons. When you add the protons plus neutrons, you are getting the mass number. Protons we have, it is 12. Neutrons we don't have yet, which is equals to the mass number, which is 24. So you group the items. We have neutrons is equals to the mass 24. When it goes that side, it becomes the additive inverse of this is a minus 12. So minus 12, neutron number is equals to 24 minus 12, which is also 12. So therefore, in magnesium atom, we have 12 neutrons. What about the electrons? How are we going to find the electrons in magnesium atom? Okay, so in this case, we said that the total number of protons and electrons are are equal in the neutral atom. How do you know that this is neutral? It doesn't have charge. When magnesium is charged, it has a positive charge. So we know that it is charged when you have that kind of a sign on top of the symbol. But because we don't have, there is neutral. So the total number of protons and electrons are the same. Therefore, we have 12 protons. It's not always that you have the same numbers like that. That's a coincidence. Maybe we do sodium, the one which have a different in this one. Sodium, another example, the last one. Sodium. Sodium has the mass number 23. Sodium has the mass number 23 and the atomic number 11. We do the same thing. For protons, we said you just get the number down there. So we have 11 protons. For the neutrons, we do the calculation where we say the protons plus neutrons is equal to the mass number. Protons we have 11. 11 plus neutrons is equal to the mass number 23. Then the neutrons is equals to 23 minus 11, which is giving us a 12. It's quite is different from that one now. So neutrons is equals to 12. For electrons, we said the number of electrons is equal to the number of protons in a neutral atom. Therefore, we also have 11 electrons. We always have same these as long as it's neutral for protons and electrons. They are always the same. If you're able to calculate this, it means you have understood the atomic structure at secondary level. You really have to know how to calculate this. You need to know how to find the protons and their properties. Identify where they are found. It's very, very, very important. Okay. Now the same atomic structure can be drawn, can be written in form of the configuration. So we have what is called the electronic configuration. Electronic configuration. What is this? What is the electronic configuration? Electronic configuration is the representation of the number of electrons in form of shells, where you show all the energy levels starting from shell 1. That is what is called the electronic configuration, where you represent the number of electrons in form of shells. So, how do we do that? Now, you understand the concept. We have writing. You can write the electronic configuration. You can also draw the electronic configuration. So how do we write it and how do we draw it? If you are writing, for example, the electronic configuration of sodium, which we know it has from the calculation we did, it has 11 electrons. We use the number of electrons, or sometimes we just say we get the number down there because it's the same with the number of electrons. So you use the number of electrons when writing the electronic configuration. So sodium has 11 electrons. There is a formula which is used to determine the number of electrons which should be in a specific shell. The formula is 2n to the power 2. N represents the number of shells. If you want to know how many electrons are in the first shell of sodium, meaning where there is n, we'll be putting 1 representing the first shell. So we have 2, 1 squared. 1 squared is 1 times that one we have 2. So the number of electrons in the first shell of sodium is 2. If you use the same formula to find the number of electrons in the second shell, but remember we need to be counting this. There should be 11 at the end. So we already have 11 minus 2, which is 9. So what will be the number of electrons in the next shell? We use the same formula. We say 2 squared. 2 squared is 4, 4 times 2 is 8. So it means the next shell must have 8 electrons. If you use the same formula to find the number of electrons, it will exceed 11. We have remained with 1. So we have no choice instead to write the same 1. So this is writing the electronic configuration of sodium. You can also draw this electronic configuration by using the shells. So let's draw the same, and you try others. I'll give you some moment to research on. Let's draw the electronic configuration. Differentiate between writing and drawing. So we have written the electronic configuration. Now we want to draw this structure. So when drawing, you start by showing the nucleus. So in the nucleus, in this case, you can just write the symbol for an element, sodium, Na. Then you draw the first shell. How many electrons are in the first shell? You can use any symbols, but the common used is X. So we have 2 electrons, 1, 2 in the first shell. In the second shell, we have about 8 electrons. Electrons occur in pairs. If you look at the alphabet principles and the other principles which are used to determine this, they occur in pairs. Okay. Then the last shell, we have one electron. So that is the electronic configuration of sodium atom. If you draw it, if you write it, it looks like that. If you draw it, it looks like that. So now I want you to draw the electronic configuration of oxygen and the chlorine as well. Not only drawing, calculate their particles, the protons, electrons, and neutrons. You must find their properties. The particles, identify their particles, as well as you draw, you write first the electronic configuration, you write their nuclide, you write their electron configuration, then now you draw their structure from the electronic configuration structure. Okay, for now we end it here. Please don't forget to subscribe again, and also drop your comment down there so that I know where I should work on, and share with others so that we can be updated together. Have a blessed day.